All right, let's talk about logical operators. So the first logical operator is the AND logical operator, and this basically checks if both conditions are true. The next one is the OR operator, which checks if either one or the other condition is true. And then the last one is the NOT operator, which is represented by exclamation mark, and it reverses the state of its operand. And if that didn't make sense to you, it's going to make sense in a second. But let's focus on these two first. So, say we want to make a program that checks for the state of matter of water. So, we know that the boiling point of water is over 100 degrees Celsius. We know that freezing point is below 0 degrees Celsius. And pretty much anything else means that it's a liquid. So if we want to make a program that checks for the temperature of water, we have to compare some values. So let's go into our main function. Let's declare an int temp, and we'll have the user decide the temperature. So we'll prompt the user, cout, what's the temp? And let's just specify in Celsius. Console input, temp. All right, so the most straightforward way of using logical operators is with if statements. So we're going to use an if statement to check the value of the temperature and then execute a line of code depending on that operation. All right, let's create an if statement that evaluates the temperature using logical operators. So let's set up an if statement and we'll say if temp is greater than 0 and temp less than 100, then we will cout the current state of the water is liquid. Because if the water is greater than its freezing point but less than its boiling point, then it has to be liquid. So let's run this code and see what happens. What's the temp? Let's say the temperature is 40 degrees, some lukewarm water. The current state of the water is liquid. That's because it checked first if the temperature was greater than 0, which is true because it's 40 is greater than 0. And then it checks if the temperature is less than 100, which is also true because 40 is less than 100. Now, what would happen if I say the temperature of the water is negative 40? Then nothing happens because we don't have an else statement set up to execute any line of code. It checked this first statement, which was greater than 0, which ended up being false, so it skipped the entire block of code. All right, let's change the AND operator to OR, and let's see what happens when we run our code. So we'll do the 2 vertical bars, and this basically means if temp is greater than 0 or less than 100, run this piece of code. So let's run it. What is the temp? Let's say 180 degrees. The current state of water is liquid. Wait, that doesn't make any sense. It was greater than 100. Well, what happened here is whenever you use the OR operator, it has to check if one or the other, and it's going to go from left to the right. So first it checked if the temperature was greater than 0, and it was like, oh, okay, 180 is greater than 0. So we're just going to cout the current state of water is liquid. So whenever you want to use the OR operator, it's going to check if either one or the other. You can't use it in the same way that you use the AND operator. If you were to do it this way, you would have to flip the comparison operators and even change the output of your code. So as you can see here, I flipped them so that they're opposite, and then I also have to change from instead of saying the current state of water is liquid, I would just have to say the current state of water is not liquid. And this is like discrete math stuff. So if you run this, it should run perfectly. What is the temperature? Let's give it a liquid state of water. So like 20 degrees or 30 degrees. Yeah, nothing happens. But if we do a very high value, 200, the current state of water is not liquid, and we run this again. Let's do a very freezing temperature, like 70. and it says the current state of water is not liquid. So now I want to talk about the not operator, which actually reverses the state of its operand. All right, let's do an age verification example. Let's say we have a Boolean value called age over 18, and we'll set this equal to true for now. So right now, age is over 18. That's set equal to true. Let's create an if statement that checks the condition of the age over 18 value. Now you might be compelled to write your Boolean variable followed by equal signs true, but when it comes to Boolean values, there's no need for that. You can just have if with the name of it, and it will run the same way. Then we'll execute cout. You can enter this site. Then we'll do else. If else, then you're probably under 18. We'll cout. You are too young to enter this site. So right now we have a Boolean value age over 18 that's set equal to true. If age over 18, cout, you can enter this site. Else, you are too young to enter this site. And if we run this code, it will run as expected. You can enter this site because right now age over 18 is equal to true. Now, what was to happen if we throw in the not operator in front? Well, basically what this does is it reverses the condition of the age over 18 Boolean value. So right now with this not operator, it's saying if not over the age of 18, then cout, you can enter this site. Else, you are too young to enter this site. So let's run again. You are too young to enter this site, despite the fact that age over 18 is true, because throwing in the not operator reverses the logic. So if we were to do that, then we would have to set this equal to false or change the cout messages. But it's easier to do the former, so we'll set this equal to false. And now, if we run this code again, you can enter this site. We're back to normal again. So yeah, that's the not operator. It basically just reverses the state of the Boolean value.